we are going to discuss question number 48 of Chemistry Gate 2019. Let us go through the question. Consider the following equilibrium: SO2 gas plus half O2 in equilibrium SO3 gas. At 298 Kelvin, the standard molar Gibbs energy of formation delta Fg0 of SO2 gas and SO3 gas are minus 300 and minus 371 kilojoule per mole respectively. The value of the equilibrium constant Kp at this temperature is dash into 10 raised to 10, round off to the nearest integer. Gas constant R is equal to 8.31 joule per mole per Kelvin. To answer this question, the most important concept required is thermodynamic equilibrium constant. So, what is thermodynamic equilibrium constant? When A and B are perfect gases, we can write molar Gibbs energy of reaction is equal to mu B minus mu A, where mu corresponds to chemical potential. Mu is nothing other than chemical potential, and we know mu equal to mu 0 plus RT ln P. So, this is corresponding to mu. Now, for mu B and mu A, we are substituting to this equation, and this becomes equal to mu B 0 plus RT ln PB minus mu A 0 plus RT ln PA. So, we know delta RG0 becomes equal to mu B0 minus mu A0. Just rearranging this equation, we will get this form, that is delta Rg0 plus RT ln Pb by Pa. If we denote the ratio of partial pressure by Q, we obtain delta Rg is equal to delta Rg0 plus RT ln Q. Q corresponds to the reaction quotient. The difference in standard molar Gibbs energy of product and reactant is equal to the difference in their standard Gibbs energy of formation. So, the standard Gibbs energy of formation can be written as the Gibbs energy of formation of products minus Gibbs energy of formation of reactant. And at equilibrium, the value of delta Rg becomes equal to 0, and the ratio of partial pressures at equilibrium can be denoted as K. Then the equation turns out to be this particular equation. We are substituting the value of 0, and instead of reaction quotient, that is the ratio of partial pressure of B to partial pressure of A, changes to equilibrium constant K. So, the equation becomes 0 equal to delta Rg0 plus RT ln K. So, now we are rearranging the equation, and then we get the value for equilibrium constant, which becomes equal to RT ln K equal to minus delta Rg0. With this background, we are going to solve the question. So, what are the quantities given in the question? The standard molar Gibbs energy of formation of reactant is given to be minus 300 kilojoule per mole, and the standard molar Gibbs energy of the product is given to be minus 371 kilojoule per mole. R is equal to 8.314 joule per mole per Kelvin, and temperature is equal to 298 Kelvin. We are asked to find out the equilibrium constant Kp. So, we know that the standard molar Gibbs energy of the reaction is equal to the standard molar Gibbs energy of formation of product minus standard molar Gibbs energy of formation of reactant, which becomes equal to delta Fg0 SO3 minus delta Fg0 SO2. which is equal to minus 371 kilojoule per mole minus 300 kilojoule per mole. The final answer for delta RG0 becomes equal to minus 71 kilojoule per mole. So we have the value for delta RG0. Now from the previous equation, the value for equilibrium constant is equal to RT ln K equal to minus delta RG0. So substituting the value for delta G, and we know the value for R, which is equal to 8.314 joule per mole per Kelvin, and temperature is 298. We just have to substitute the values, then we get the value for ln Kp. So the value for ln Kp, by substituting these values, we will get minus ln Kp equal to minus 28.6, where the units all get cancelled, like mole gets cancelled, Kelvin gets cancelled. Here what we have got, delta RG0 is in kilojoule. We need to convert it to joule. So the final answer for ln Kp becomes equal to 28.6. We are asked to find out the value for Kp. Kp is equal to 286 into 10 raised to 10. So the allowed answer range is 265 to 295, where our answer is 286. So we are asked to round off to nearest integer, like we need not represent it in decimal, only in the form of integer. So for more details on this topic, please go back and watch NPTEL video on the topic Chemical Equilibrium Part 1 by Professor Arjit Kumar De, Isa Mohali. The YouTube link is also attached here. Thank you.